So this is just a quick warm-up to make sure we're feeling good on finding area of circles. This was something we did last week. So go ahead and try this on your own and then watch the video solution once you're ready to double check your work. So we are trying to find the area of the shaded region. That's the gray area here. So the big idea of how we could find that is if I could find the area of this square and subtract the area of the circle, then I would get those little corners per se. So that's like the big idea of what we're trying to do. So let's work at finding the area of the square first. The polygons are regular. All that means is that the square's 4 sides are equal, and they all are 8. So the area there is going to be base times height, which is 8 times 8, or 64 units squared. We don't have specific units. And then let's think about what the area of the circle would be. So if I want my area, I need to use the formula, which is pi times radius squared. So I need to know how far across it is. So from the edge to the center. Now, the only information I have is that this distance is 8. Notice, if I have 2 radii, or the diameter is going to be 8, which means just one radius is going to be 4. So it's going to be pi times 4 squared. 4 times 4 is 16, so you can write it as 16 pi if you want it to be the full exact answer. So what you'll do on your calculator is you're going to do 64 minus 16 pi. I'm going to pull up my calculator real quick. So I can do it in a couple different ways. I could do 64 minus, and the little scientific ones have this too, where you can put a parentheses, 16 times, and then to get my pi, it's the yellow button, followed by the kind of upward caret that has the little yellow pi above, close the parentheses. So I can do it in this fashion. Notice I'm using the pi button, that means this is the exact answer. So it's about 13.73 units squared. The other alternative is to do 16 times 3.14, right? And then do 64 minus about 50.24, right? That's the approximate answer. Notice 76 versus 73, right? They're pretty close. Generally, we have it down to 1 decimal point matching. It's the second point that it will be a little different. The other option you have here is to do like 16 times pi. And then another way you can get the answer is to do 64 minus the second button, and then the little negative has an answer above. If you call back the last answer, that's another way to do it without the parentheses. So lots of different ways. Feel free to just use the decimal approximation of pi being 3.14 to simplify your work. Okay, and your calculator might not be exactly the same as mine, so feel free to let me know if you guys have any follow-up questions on how to use the calculator for anything specific. Okay, so our new vocab for today is sector area and arc length. These are 2 different things. And sector area is really connected to the idea of area of a circle. So instead of having the full area, the sector area is area of part of the circle. And for an example, here's a good example down here. This is a survey that was given through like Google Forms, and 49 people voted on Popeyes versus Culver's, which restaurant is better. So this, the red area, let me get a different color just to show the difference. That is a sector, and this is a sector. So these are 2 sectors. So sector area is when you do area of a piece of the full circle. And then arc length is the second big idea. So make sure if you are kind of listening to pause the video at this point and maybe do like a little picture, a little explanation of what the vocab word means generally for sector area before moving on to arc length. Arc length is really connected to circumference. So arc length is going to be like maybe this much. So it's going to be a part or a piece of the circumference. And these are useful because sometimes we, depending on a problem, don't need the full area or circumference, but we only are really concerned about a part of it. So we're going to kind of see some examples of what that looks like. Okay, so make sure you've made a note of our 2 new vocab words and maybe a small picture. And we've got 4 quick problems. So this is our first example. This is a sector area problem. And we're asked to find the area of the shaded sector below. So notice we're not looking for the full circle, we're looking for a piece of it. So I generally think about this as it's a percent or a part of like the area. So that's like the big idea I like to connect to, is it's a part of the area, right? So it's like, if we find the total area, let's think about what the total area would be first. So the total area would be pi times radius squared. That's our area formula. So my pi stays the same. Notice my radius is from the center to the edge. That's going to be 8. It's halfway across the circle. So that's going to be equal to 64 times pi. I'm just rewriting with the number in front, kind of like 64x compared to x64, right? We conventionally put coefficients in front. So that's the total. Now, if I only wanted a part of it, let's say big picture, if I want half of the area, right? I could do that divided by 2 if I want half of the circle, right? If I'm just doing this amount, I would do a half of 64 pi. You can think about it as multiplying by 1/2 or as dividing by 2. Okay, we're going to do the same thing here. The only thing we have to figure out is what our percentage is. So here's what I'm going to do. I'm going to take my 64 pi and do the percentage times 64 pi. So if I don't know what the percentage is, here's how I can do it. This is a 90-degree angle. All the way around is 360 degrees. So you'll do 90 out of 360. Now that's actually going to be a quarter of the circle. If you simplify your fraction, you'll see that 90 divided by 360 is actually going to be 1/4. See? 0.25. So if you know that it's a quarter, you can just jump to the 1/4. But I like to show you the big picture like generically so that you could approach any problem with the same way. So we would do a quarter times 64 pi. So I would just do 0.25, right? That's a quarter, times 64 times pi. So my full exact answer is going to be 50.27 if I round up, units squared. Now, you also, if you wanted to, could do the 1/4 times 64 times 3.14. That would get you to 50.24. So that's exact 50.24 units squared. That's with pi being about 3.14. Doesn't matter which way you do it. You can do it whichever way you want, as long as you make it clear if, if you're using 3.14 or not. But I'll be able to tell. So that's the general idea. So big idea is a percentage times the area, right? And I'll rewrite that here. Percent times circle area. So that's like the big idea that you want to take away for the area of a sector. Now, the next problem you're going to do is going to be on your own. You're going to try it out, and then you're going to check your answer against mine. So here is a practice problem. So go ahead and practice finding the area of a sector, and then once you're ready, check it against the key. Okay, double check your steps. I've shown my work for getting the area of the full circle and finding what percentage of the area we want. And then on my calculator, you can see the calculations I did. I did use pi is about 3.14. If you did the exact answer, take a look at the calculator one more time. I've put that in too. You should get about 113.10. The 9 will get rounded up based on the 7. Okay, so here is big idea number 2. Big idea number 2 is going to be looking at what's called arc length. So these next 2 problems, we're going to do one together and then a practice. They're going to deal with the circumference rather than the area. So remember, we're looking for a piece of the circumference. So the circumference formula is 2 times pi times radius, or it is pi times the diameter. Remember, circumference is all the way around the circle. It's basically like the perimeter of the circle, but because we don't have multiple sides, it has its own name. So we're actually going to approach this in the same way. It's going to be a percentage of the circumference, which is really nice. So it's really well connected, these two ideas. So let's first find what the circumference is, right? I'm going to do 2 times pi times the radius. My radius is 18. I can do the 2 times 18. That's going to be 36. And then I'm going to put that in front of the pi. And then same thing. I want the percentage of my circle. The percentage of my circle, what's really nice is if you think about, let me just get a highlighter, this amount compared to all the way around, right? That amount is going to be the same percentage of this compared to all the way around. So it's still going to be the 40 degrees over 360, which is really nice. So for my final calculation, I'm going to do the 40 over 360, the percentage, times the circumference, 36 pi. So let's get the calculator out to see that. So 40 divided by 360, and then I need to do that times 36, times, I'm going to use 3.14 for pi, and it's going to be 12.56. Now, here's the one thing. Before, when we were doing our sector area, it was units squared because it's an area. Remember, now that we're in circumference for arc length, it's going to be units. And you can just write a U if you like. If you wanted to do the full exact answer, you would do the same thing, except for we would use the pi button. So I'm just going to pull that up real quick. Full exact answer would be 12.57. So just a tiny bit difference. You'll see that it's typically pretty close. I'll make a note that that's exact. Okay, so that's one example of what arc length looks like. You're going to try a practice problem on your own, and then you'll double check your work against the key. Okay, so here's your practice problem. You are looking for the arc length of AB, right? Notice this notation here is representing the arc A to B. Otherwise, it would be referencing like a cross, right? We don't want the segment length AB. We're looking for the curve along the edge of the circle. So that's a real important thing to notice. There's that way that we are noting it. Okay, so you've got your radius as well as a degree measure, right? As a quick hint to find this degree, remember, a straight line has a certain angle measure. Okay, so go ahead and try it on your own. Double check the answer key when you're done. Okay, there's your final answer. So double check, make sure that you notice the left answer option is using pi being 3.14, and the right is using the pi button, which is the exact formal answer. Okay, so that's it for today. Hope that these couple of practice problems of each type have helped clarify the big idea.